this video, what we're going to do is we're going to start talking about conditional statements, what they are, and how to formalize them. Let's get into it.
The first connective that I want to talk about is the notion of the arrow. So this is the conditional statement, or just called a conditional for short. Sometimes you'll see it be called an implication or a material implication. That's fine too. Basically, these are if-then statements. Okay, and there are others. There's, like I said, conjunctions or and statements, and disjunctions or statements. We're going to spend the first bit of time here talking about conditionals, if-then statements, and how we translate them into formal language, and also how we deal with them. So I think let's start with an example. If I say something like this, if I say, if the power is off, then the lights are off. So if I just saw this by itself, there are two words in here that let me know this is a conditional statement. One is the word if, all right, and then there's also the word then. So then it becomes a matter of translating it. So since this is a compound statement, there's actually two statements in here. One is this one. There is just the statement, oh, the power is off. Let's underline power, and that means just saying that the power is off is just P by itself. What does this mean? The power is off. And there's another statement in here, the lights are off, and let's just underline that one here. We'll say, how do we represent the lights are off? L, based on what I've done here. All right, so P by itself would just mean the power is off. L by itself would just mean the lights are off. How do we represent this as a conditional? Well, conditionals are if-then statements, and basically it works this way. Whatever follows the, and I'm going to use some peculiar language here, I'm going to say whatever follows the phrase if. I know it's a single word, but I'm going to say that now because when we get to other concepts later on, like the notion of only if, that will make more sense. So I'm just going to say whatever follows the phrase if goes on the left side of the arrow, and whatever follows then goes on the right side of the arrow. So I'm going to go ahead and draw an arrow here. And I just said whatever follows if goes on the left side of the arrow. So here we've got this. P follows if, so it's going on the left side of the arrow. And then whatever follows then goes on the right side of the arrow. So I'm going to put L. So here, this right here, I'm going to just call it for here, F1. This is our formula we're using right now. So what this says, this P arrow L, it's standing for the English statement, if the power is off, then the lights are off. That's all this means. If the power is off, then the lights are off. And that's really all we're doing with formal logic here. Now we're going to do some other things with this, because sometimes things can be implied, and I'm going to show that here in a moment. So I said here a moment ago that sometimes the aspects can be implied. So I said, if the power is off, then the lights are off. But I use the word then. Sometimes we can take it out and it still works. So like this. So if I said this, if the power is off, that if is still working to let me know, hey, this is a conditional statement, and I'm going to underline the same things. So even though there's not the word then here, the comma here is kind of doing the work of the word then. We can say this. I can say, if the power is off, then the lights are off. But I might not. I might say, if the power's off, then I'll pause, the lights are off. So what do we do with this? Well, like I said, the comma is doing the work of the then there. So it would still be, with this arrow, whatever follows if goes on the left side of the arrow. This would be P. Now, if the power's off, then the lights are off, even though it didn't say the word then there. So even if the word if were not here at all, someone could do this. Someone could say, power's off, lights are off. How would that be represented? It's actually still a conditional, and it would be this. Just the if is not there in English. Now, you can do it that way. It's a little less clear, and probably on a quiz I wouldn't give you one like that, but it still functions as a conditional statement because the if and the then are implied. So the then's not here. I could have stuck it here. I could have said, oh, then, and the if could be there, or maybe not. Maybe they're not. It's still a conditional statement. Now, for the purposes of a quiz, I'm going to make it as explicit as possible. I'm not going to go out of my way to put things there or to not put things there to try and confuse you, because I want to focus on clarity. on our quizzes here, but you could put it that way in English. And what this does is just simplifies it down. Now, why do we want to simplify it down? Why formalize this stuff? Well, because it lets us do other things to figure out what's going on with the words that we have and reach conclusions that we wouldn't be able to necessarily otherwise. So let's look at the first thing that we can do with arrows and conditional statements. And so the first thing that I'm going to introduce here is a rule. And this rule is called modus ponens, or sometimes modus ponendo ponens. And I'm going to refer to it as arrow out. So that's going to be my shorthand for it. But the rule is technically modus ponendo ponens, which is a Latin phrase that just means mode or way that affirms by affirming. So mode that affirms by affirming, you don't need to know that, but it's called modus ponens, or I'm going to call it arrow out. And it works this way. It just says this. Here's the setup for it. It says if you have the following situation, then you can get the following result. So here's the situation. If you have an arrow, okay, and I'm just going to put A, arrow B, and you have it as, I'm going to stick over here in the right column, this is an assumption. All that means is this is what you've got. And then you also have the left side of the arrow by itself as an assumption. So it just says you got this. Okay, so let's fill some stuff in here. Let's say A stands for the power is off. And let's say B stands for the lights are off. Okay, let's plug them in here. If that's the case, if these values are what represent these variables, then what would we get? We would get, okay, if the power's off, then the lights are off. And we're going to say, oh, what this means is you've been given this. It's true. Okay, so imagine this is what it's saying. Imagine that if the power is off, then the lights are off. Then you also have, as a separate thing that's been given to you, hey, the power's off. Well, then what do we know? What can we, and this symbol here, it looks like a T on its side, what can we conclude? Well, if it's true that if the power's off, then the lights are off, and it's also true that the power's off, then we know, we can get here in step 3, hey, the lights are off. That's B. And what I'd say over here in the right column is, hey, that's arrow out. That's the rule here. It means this. If you have a situation where you have an arrow and then you have a match of the left side, you can get the right side of the arrow by itself as a deduction. And then what you want to say here is, okay, what were the pieces that let you get that? Well, we just cite the rule. If you got an arrow and the left side of the arrow by itself, you just say those. Hey, so I did arrow out on lines 1 and 2, and I was able to conclude this B here, and B stands for the lights are off. So what this means is, again, if the power's off, then the lights are off. If that's true, and also this is true, hey, the power's off, then I can conclude, hey, the lights are off. And this is one of the first deductions. This is one of the most basic rules of inference that we have in logic. If something's true, then this follows. Hey, this is true. Hey, then that follows. And let's take a look at a couple more examples with the same model here. Okay, like I said, this arrow out thing, modus ponens, is one of the simplest kinds of logical deductions. And here's its shape. If you have an arrow and you have a left side match of the arrow, then you can get the right side. So if I just put a little bit more in here as assumptions, just label things. Let's say these are assumptions. What do I mean by assumptions here? These are things you've got. Then you can conclude this. So if you've got these as assumptions, you can conclude this via this route. So you know modus ponens from these first two premises here that this is true. And we can plug all kinds of values into A and B. So let's do some others. Let's say A stands for today is Wednesday. B stands for tomorrow is Thursday. So if we plugged these values, if A stands for today is Wednesday and B stands for tomorrow is Thursday, here's what we've got. Line 1 here would say, if, because of that arrow, if today is Wednesday, then tomorrow is Tuesday. Well, let's say we've got that. If today is Wednesday, then tomorrow is Thursday. We've also got separately, hey, by the way, today's Wednesday. Then what do we know? Tomorrow is Thursday. How do we know that? Modus ponens, arrow out, from these first two lines. We know this from this and this put together. And so modus ponens is the shape, arrow out is the shape. Again, if you got an arrow, you got a left side to match. So first of all, what you should do is look for an arrow and see what's the left side of the arrow. If you have a match to the left side of the arrow by itself, that means you can get this right side and stick it by itself. That's something that you can deduce. So we're going to look at a couple more examples of where we can employ this, and we're going to see what else we can do with this information. What I want to do now is look at a couple of pieces from the book. We're going to look at number 1, A through F. Number 1 is on pages 20 through 21. And so here we're just translating stuff. We're putting stuff into formal notation. Now, whereas I have done things a while ago where I was underlining stuff. So I was saying things like, if today is Wednesday. I might say this, then tomorrow is Thursday. And I said something like that would be W arrow T. If today's Wednesday, then tomorrow's Thursday. What we're going to do is we're going to do some stuff out of the book and see if we can translate it. And this is again on page 20. It says, if I die for Islam, then I go to paradise. Now, whereas I've been underlining things, the author of your textbook just puts them in all caps. So it says this, if I die for Islam, then I go to paradise. Well, that one would be, there's an arrow. Anytime we see an if then, we can go ahead and stick an arrow. And whatever follows if goes on the left side of the arrow. So it says, if I die for Islam, then I go to paradise. The next one, B, it says, if the oceans die, we die. That's an arrow. If the oceans die, we die. The third one, if ticket is lost, regular toll from the farthest point will be collected. Now notice this one, it has the word if, but it doesn't have the word then. So this one, if the oceans die, now remember, whatever follows if ticket is lost, that goes on the left side of the arrow. So whatever's left is going to go on the right side of the arrow. In this case, regular toll from the farthest point will be collected. C. D. This one's a little bit different. It says some 7,000 employees of Southern Bell in Dade County would be affected if a nationwide strike of Bell Systems workers goes into effect. Well, that's still an arrow. But here the order in which it was given in English is a little different. It says some 7,000 employees of Southern Bell in Dade County will be affected if a nationwide strike of Bell Systems workers goes into effect. So here, like I said, it's still consistent. Whatever follows the word if goes on the left side of the arrow. So what follows the word if here is a nationwide strike goes into effect. If this happens, then some 7,000 employees of Southern Bell in Dade County would be affected. So in spite of the order in English being kind of backwards, whatever follows if goes on the left side of the arrow. E. This is a quote from Margaret Thatcher, Prime Minister of the UK. I am extraordinarily patient, provided I get my own way in the end. Oh, this one doesn't say the word if. Well, here, the word provided is a substitute for the word if. So if that's the case, provided I get my own way in the end, then I'm extraordinarily patient. And then here, F, should the Dolphins qualify as a runner-up team, they will play at Cleveland Christmas weekend. Well, the word should is another example of a synonym for if. Not should in a moral sense, like should you do this, but should like if this should happen. You see there, I had the word if in there, so I'm going to stick an arrow there. Whatever follows the word should goes on the left side of the arrow. In this case, should the Dolphins qualify, then what will happen is they will play Cleveland Christmas weekend. Let's take a look at a few more in number 1 on page 21. G says San Diego can clinch the AFC West crown by beating Denver in their final game. The by here, the word by, is the substitute for the word if. So we're going to take that, and whatever follows that is on the left side of the arrow. So we know it's an arrow, and we know this one's going to be an arrow. All these are going to be arrows. Conditional statement. Whatever follows the if here, in this case the by, goes on the left side of the arrow. So again, G says San Diego can clinch the AFC West crown by beating Denver in their final game. So if they beat Denver in their final game, then they can clinch the AFC West crown. H says, had the stowaway refused to obey, the pilot would have used the blaster. First of all, that had means if in this case. And then there's a comma in there, which means the then. So, in other words, I could say if the stowaway had refused to obey, then the pilot would have used the blaster. And so that would be this. And then finally here, as long as it's fair, I'm going to win the job. So the as long as also means, in this case, if. So as long as it's fair, if it's fair, then I'm going to win the job. Now the next few here, J, K, and L, are a little bit different. And here we have to review the concept of statements being dyadic and well-formed. Now for number 1J on page 21, we've got this. If the axioms could be, so that word if, I'm going to go ahead and stop there and stick an arrow. Okay, because if there's that, whenever it follows if goes on the left side of the arrow. It says, if the axioms could be so selected that they were necessarily true, then if. Oh, there's another arrow. So whatever follows the first if goes on the left side of the first arrow here. So if the axioms could be so selected, so A is going here. If the axioms could be so selected that they were necessarily true, then if the deductions, so deductions is going on the left side of this arrow, then the truth of the theorems could be guaranteed. So we've got this now. We've got A, arrow, D, arrow, T. So this one's new. It's got 3 constituent components, not 2. Is this done? The answer is no. It's not. Why? Because one of the things I said about these formulae is that they need to be dyadic. That is, they need to be 2-ish. They need to have a left side and a right. This is 3-ish. It's got 1 part, 2 part, 3 part. So what we're going to have to introduce here in order to finish this off is we're going to need parentheses to group them together. So I'm going to give you a cheat for this. Basically, it's going to work this way. If ever you see this pattern, if ... then if, as we did here, we saw this. If the axioms could be so selected that they were necessarily true, then if, right there. That means that this has a heavy right side. That means everything following the first if actually goes together. So how do we represent that? We're going to put parentheses here and here. So now this is dyadic. This is the left side, this A here, and this is the right. So whenever you see this pattern, if, then if, that means you got a heavy right. This is still dyadic now. It's got 3 components, but it's dyadic. This is the left. If this, then this stuff. That's how it works. Sometimes you can have a heavy left. Like you have a pattern where you've got this. You could have arrow where it's got a heavy left, and then arrow, and then something over here. What do we do in that situation, or what yields that situation? It's basically this. If, and then you'll see later, if all the preceding, or if all of the above, then if you see this pattern on the other hand, that means you've got a heavy left. We're going to look at a couple more examples here with K and L and see if this pops up. So now let's look at K. It says this: if you have a specific question, we will relay it to him if he calls in. So this one's a bit tricky, and I don't think I give you one like this on a quiz, but here's what it says: if you have a specific question. So remember, whatever follows if goes on the left side of the arrow. So if you have a specific question, then what? And it says this: we will relay it to him if he calls in. So it's kind of backwards, but there's the other if hiding there, which means here's another arrow, and we need to put parentheses here on the right side. In other words, if you have a question, then if he calls in, we will relay it to him. And so it works this way, the heavy right side. Let's take a look at L now. If U.S. Shipyard's own bid to acquire the property fails, the company would be interested in a lease so long as the payments are reasonable. So here again, the first word is if, which means we know there's an arrow. What do we have following it? If their bid to acquire the property fails, then what? The company would be interested in a lease so long as, so that so long as is another if, which means this is also another heavy right side. A little bit more ambiguous here. But so whatever follows, so as long as, which also means if, would go on the left side of the arrow. So that would be R. Payments are reasonable. then they'd be interested in a lease. So what this one is saying is, if their bid to acquire the property fails, then if the payments are reasonable, they'd be willing to do a lease. They'd be interested in a lease. And here's what I'd want you to know for a quiz. Basically, if you see this pattern, and I'm going to put some letters in here. If you see if A, then if B, then C. If you see this pattern, if, then if, that means you've got A arrow, B arrow, C. Heavy right side. So it's still two-ish. Here's the left side. Here's the right side. The right side is heavy if you see this pattern. If, then if. So let's look at when we could have a heavy left. If you saw something like this, if A, then B. And then it stopped there and said, if all of the preceding, or it could say if all of the above. Okay, if it says if all of the preceding or something like that, then C. What that means is you have this pattern. You have if A and B, and then all of the above. What's all of the above here? All the preceding. If you have all this, then you can get C. So if you see this pattern, you'll have a heavy left side. So this is the left, and this is the right. So it's still dyadic, left and right. This, on the other hand, if you see if A, then if B, and then C, something like that, this is the left side, and this is the right side. This is a heavy right pattern, and this is a heavy left pattern. I'll give you a couple more examples of this as well as we get to the quiz, because these examples here in the book are a little bit more ambiguous than I'd like, but we'll be looking at some other concrete ones here shortly.
Okay, so that was an introduction to formalizing conditional statements. What we're going to do next time is we're going to look at some more problems from the book and some stuff that we can do with conditional statements. See you next time.